Did you know that every time you cook, you're using stoichiometry? Just like a recipe where specific measurements are required to make the perfect meal, chemical reactions need the exact right amount of reactants to produce products. This intricate balance is called stoichiometry, one of the most fundamental concepts in chemistry. Let's dive in. Stoichiometry is the study of numerical ratios of reactants and products in a chemical reaction. It allows us to predict how much of a substance is needed or how much of a product will be formed during a reaction. This is all based on the law of conservation of mass, which states that matter is neither created nor destroyed, only transformed. Before getting into calculations, let's review the basics. Please note that this video is not intended to teach you everything you'll need to know for stoichiometry. We suggest that you have a good understanding of reaction types such as synthesis, decomposition, single replacement, double replacement, and combustion, and also know how to balance chemical equations. Before using stoichiometry, it is crucial that we are working with a balanced chemical equation. This means that the number of atoms of each element on the reactant side must be equal to that on the product side. Many stoichiometry problems require the use of moles, which are a way chemists measure the amount of a substance. 1 mole contains 6.022 times 10 to the 23rd power of particles. This is Avogadro's number. Molar mass is the mass of 1 mole of a substance in grams and can be found on a periodic table. Thus, we rely on mole ratios, or the ratio of the coefficients in a balanced chemical equation, to tell us the ratio of reactants to products. Now that we have a foundation, let's go over some common types of stoichiometry problems. We can use this chart to visualize each step in our dimensional analysis setup. In this first problem, we can use a given mass of one substance and use stoichiometry to find the unknown mass of another substance. First, we'll balance the given chemical equation, and then we'll set up our dimensional analysis table. We'll convert the given mass to moles, and use the mole ratio from our balanced equation to convert from moles to grams. In the second problem, we will convert from moles to particles. Again, we will start with balancing our given chemical equation. Next, we'll use the mole ratio to convert from moles of one substance to another. And lastly, we can convert from moles to molecules using Avogadro's number. Now it's your turn. Pause the video and try these practice problems on your own. The answers will be revealed in a few seconds. Good work. Let's recap the lesson. Stoichiometry is based on balanced chemical equations, which provides us with molar ratios for conversions. Molar mass and Avogadro's number are most commonly used for stoichiometric calculations. Remember to use dimensional analysis to avoid errors. Now you've mastered the basics of stoichiometry. Thanks for watching.